All right, distance learning stat students, we begin our chapters today. All right, we are in the first unit, chapter 4 in the textbook. You should have your textbook by now. So, we're going to be talking about designing studies. In the last video I sent, we talked about how the cigarettes cause cancer. We saw there was a lot of studies that had to be done to do that. Then we saw a article from a study from the American Stroke Association or Heart Association. They did research and they had to do that properly as well. So this lesson is all about designing studies. Okay. So you need to have your notebook, and what I'll have you do is go ahead and title it like I have here in your notebook. And for this class, we do take a lot of notes, and you will fill up your notebook. I think last year I had a girl that said, this is the most notes I've ever written for a class. But the same girl said this is the only notes that they've taken where they thought they were useful. So, there's that. And you can see if you agree or not. Okay? But this is the way I've found is the most efficient for teaching statistics. So here's what we're going to start off with here. Okay, we're going to talk about how to experiment well. And as I said, we can trust. We had that article of the American Stroke Association. We had that article, and we trust that they knew how to run an experiment or run a test. Right? We knew that we knew that we could trust that. They were credible. They were not Joe Schmo on there just messing around. Okay? So the biggest issue in a study is what's called bias. Okay? So we're going to write that down. And that's going to be the main point here. And we're going to start with that. Experiments must eliminate bias. So that's really one of the big things, right? And especially when you're dealing with humans. Let's talk about the Stroke Association, right? If they're sampling people, it just depends on who they are. If they're healthy or not healthy, if they're old, if they're young, you have to make sure that you're eliminating as much bias as possible. And that, of course, I'm alluding to the idea of sampling and picking a good sample. But let's just start with the bullet points here. Got to eliminate bias. And then the last time we wrote down a definition called confounding. So we have to control confounding. As much as possible. Okay? These sort of go hand in hand in a way. Confounding, it's very hard to eliminate confounding. You can eliminate bias if you make very even groups that you're experimenting with, to where you can say, okay, this is fair, this is even, there is no bias towards anything. But confounding is very tough to control, like we talked about. Did the vape cause the stroke or the increased risk, or was it just genetics? Like, you can't look at somebody and tell, hey, you're genetically going to have I can tell you're not going to have a stroke, or you are. Okay, so sometimes there's things that are out of control, but you try to control it as much as possible. All right, and the answer to doing both of these is choose the perfect sample. We'll say choosing the perfect sample. All right, that is the goal. All right, we've got some definitions that we're going to write down to start this off, because we are going to talk about them so much this year. They need to go ahead and be defined. So for the first time out of many thousands of times that it's going to be used this year, the word sample. leave yourself some space. The word census. Actually, I'm going to write that one last. Sample population. We'll be using that many times this year. So sample and population, and then census. So let's go ahead and talk about sample and population and how it's going to come into play as far as grades for you. Part of your goal will be to identify a population or a sample from a problem. Let's go ahead and define these. Okay, so right here, go ahead and write these definitions. I'll highlight what I'd like you to write in here. Let me, I'm not allowed to edit these. Go ahead, population, and you can just write the entire group of individuals we want information about. If you want to pause the video to write it, go ahead. Census, well actually let's do sample, is a subset of individuals in the population from which we actually collect data. So you can pause and write that. And then a census collects data from every individual in the population. Okay? And we have this little diagram here. So the population is, here's the sample space, I guess you'd call it, kind of. Your population, you're picking a subset of that population. And the goal, the reason for this is that, let's imagine that I want to get the opinion of America. Do I want to collect data from every single individual in America? No, because that takes forever and it's expensive, and I have to, who's going to go do it? How many people do I need to hire to do that for me? There's a lot of complications. So can we get by with a sample that will do the same job? Well, yeah, we can, but we need to make sure that it is, here's the key word, representative, okay? And that's that idea of bias. You know, we don't want a sample that doesn't look like our population. That is the key, okay? So we collect the data about the sample, or we collect data from that sample and use that to make a judgment, okay? They made the judgment in the articles you read that vapes increase the risk of strokes. That was the inference that they made on the population based on what they collected. Okay? So those are the key words here. Now, to eliminate bias, we need good sampling. Got to have good sample. So we got to choose the perfect sample to eliminate this. All right? And to deal with those up there, the confounding and the bias. Okay, so let's start with this. Let's talk about bad sampling. Let's talk about how to do it poorly before we talk about how to do it well. Okay, we've got some more definitions we're going to write down. First one is bias, so we talked about it a little bit. We have what's called a convenience sample. And then we have what's called a voluntary response sample. Okay. So we're going to define all these real quick. Leave yourself some space for these in your notes. All right, let's find those. All right, so we'll start with the word bias. So as I highlight what you need to write, you can pause. So it says the design of a statistical study shows bias if it would, when you consistently underestimate or consistently underestimate or overestimate the value you want to know. Okay, that's very important. And I want you to underline the underestimate and overestimate. All right, because you are in a stats class, and if I wanted to know what is the average GPA of Stewart's Creek High School, and I only grabbed from my stats classes, that would be probably an overestimate because it is an advanced math class. A lot of the students in that class are more academically inclined typically, okay? So I would not base my GPA calculation or estimation for Search Creek by picking you guys as a sample. Now, the type of sample that it would be for me to pick you, because I see you guys every day or have your emails or whatever, that would be a convenience sample. Go ahead and write this. Choosing individuals from the population who are easy to reach. Okay? So yeah, it would be nice if I could have all that work be done very easily by saying, okay, I want to figure out the average GPA. Well, let's go average ACT score, and I pick my stats students because they're easy to access. Or even my integrated math 3 classes, they're honor students as well. That's still going to overestimate it. Okay? Still going to overestimate it. All right? Or if let's talk about bias a little bit more. What if I want to find the average height of students in my school? Well, if I only went to freshman teachers for whatever reason, maybe the person next door is a freshman teacher, that would underestimate. There would be bias in that sample, right? All right. Next, voluntary response samples consist of people who choose themselves by responding to a general invitation. All right. So I want you actually to write. So we're going to write actually all of this here in your notes, so you can pause if you need to. But voluntary response samples show bias because people with strong opinions, often in the same direction, are most likely to respond. So this always makes me think of being, and I'll let you keep writing that, and you can pause if you need to, but then I'm going to tell a story. So I was a waiter at Bonefish Grill throughout my college career. And I still do it during the summers, as a teacher. I didn't this past summer because of Corona. But we would print out these surveys, and maybe you guys have jobs, and y'all give out little satisfaction surveys. Now, most people don't really care about them and don't really fill them out unless they have a strong opinion. What does that mean? Well, usually the people who are angry are the ones that fill them out. So what you get is bias, right? Because these people are saying you're bad, when really it's probably not. Your percent of your customers don't feel that way, right? So that's the idea of voluntary response. So it's all bad, and you don't want to send out an invitation and just take whoever will reply. Those people are very motivated to do it, okay? That's usually the case, all right? All right. So those are how things can go bad. So let's talk about how to sample well. All right. So what we need to take is called, and we will use this thousands of times this year, a simple random sample. And we have an abbreviation because we'll get tired of saying simple random sample. We call it an SRS. And you absolutely can say SRS when you're describing this. Okay? All right, so we're just going to focus on SRSs to finish off this lesson. There are other sampling methods that we're going to get to, but we are not going to worry about them for this section of our notes. Let's go ahead and define it though. Let's do a simple random sample, and we're going to say of size n. Let me add that. It's very important that you oh no, okay. Of size n, So I've been making videos all day today. Okay. All right. So simple random sample is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. Okay, so if I want to sample 10 of my students in my stats class, if the population is all my statistics classes, which would be the population, let's say I pick 10, every group of 10 individuals has the same chance of being selected. That's what that means. Okay, that's what that means. All right. So you can pause and finish that. But random sampling is the way to eliminate bias. It helps. It completely helps because right here it says it is a sample chosen by chance, and it rules out both favoritism by the sampler and self-selection by respondents. I use this in tennis to pick teams that are going to be sort of they call it king of the court, and I will use this to pick them, right? So it's sort of my go-to method for to where I don't have to think about it and nobody's feelings are hurt, and anybody can be the king. It's not just that I pick my favorite or anything like that. Not that I have favorites. So we're going to practice taking a simple random sample, and I'm going to put an image in your PlayPosit. We're going to be doing this two ways. We're going to be using a table. It's called Table D of random numbers. And technology. So we're going to be using our calculators essentially. And since most of y'all won't have calculators at this point, use what you have. If you want to use like Google random numbers or something like that, that's fine with me too. But you can figure out a way to do that when you're doing your worksheet that I'm going to assign for this. So let's start with the random digits table. Okay. All right. So we're going to, for both of these, what I'd like you to do is I'm going to pause this. I know it's a slide already, but I would like both of these to be written down, if you would. So for choosing an SRS with technology, you can pause the video, write down both of these steps for me. In your notes, you have Table D random digits and technology. So go ahead and write out this slide here, okay, in your notes. All right. Pause it. Make sure you've got that. Then this is what we're going to practice doing. We're going to practice both of them, but how to choose an SRS using Table D. Okay, that's what we're going to do. So step one, label each of the members of the population a numerical label with the same number of digits. Use as few digits as possible. And then you're going to read consecutive groups of digits of the appropriate length from the table from left to right across the table. All right, so write all that down, pause it, write it, and then we're going to explain it step by step. Okay? So they have an example on the next slide that we'll look at. We'll go ahead and go here. I don't like how this is displaying. Okay, no, I don't. My My screen's all messed up now. Okay. We're getting back to normal now. I have no idea what just happened. Okay. Alright, so we're going to do this a little bit differently. Okay. Alright, so I'm going to pull this up on here to show you guys. So if you haven't already logged into your book, that link that I sent you will work. If we go to whatever class we're in here, open up the book, and we go to the back and you have appendices here. We want tables and we want random digits. Here they are. Okay. So what we would do, and we'll practice with this one, is we would pick a very random line here to pick our sample. So we're not going to use what they have in here for this. We're going to do something different. Okay. My slideshow is not working the way I want it to, so let me see if I can change it to. Let me get to it. I can actually make this work now. Okay. All right. So let's practice with this table over here first before we do what they have here. Okay. So we're gonna pick a line here. It doesn't really matter. I'm gonna randomly choose one. I wish I had a random number generator to pick a random number line here. Let's just go with 124, whatever. All right, so then I'm going to start and I'm going to read every two numbers. Oops, sorry. What number? I said one, and I forgot which one I was going to do. One. I want to make sure it's one you can see. Let's just do 121. Okay, 121. So I'm going to go every two numbers in this book, and I'm going to look to see if that's one of my hotels. So I start with 7-1. Well, that's not one of them, right? Then I'm going to go 4-8. That's not one of them. 7-0. Nope. 9-9. Nope. 8-4. 2-9. That's not one. 0-7. That is one. So my first one that I got here is Cabana. Okay, so I got Cabana. Then I go 7, skip to 1. Nope. 4-8. 6-3. 6-1. 6-8. 3-4. Nope. I'm just going to go ahead. Once you get to the end, there's more to this row. But once I get to the end, I skip back to the next row. So I go 1-3. Okay, so the next one is Lime Tree. Okay, so I got Cabana and Lime Tree, and I just keep going. 8-7, 3-8, 1-5. The next one is Palm Tree. So Lime Tree, Palm Tree, and Cabana. I need one more. 9-8, 9-5, 0-5, which is Beach Castle. I'm done. So we're using this random number table to help generate our sample. So let's look at what they have. Here's their number line. So they picked a number, random digits table, and they're going to go the first one here. So we look at the numbers here. 69, nope. 05, they got Beach Castle just like us. 16, Radisson. 48, nope. 17 is the Ramada. There. So watch what happens here. They get another 17, but you don't count it because, and look, they get another one right here. 17, 17. You don't count it because you've already picked it. You don't want to double count your sample. So we go all the way through this until the last one is 20, so we get C Club. And that's our sample. So Beach Castle, Radisson, Ramada, and C Club. Okay? Now, if we wanted to do this with technology, let me show you this on both the TI-80, for those that might be using it, just if you are. So on the TI-80 series, if we press Math, we go to probability and we do random integer. We put a lower boundary. We want go from 1 to, we have 28. N is the number, is our sample size. I'm just going to start with 1 and hit enter. I want 1. So 27. So that's tropical shores. 26. The problem with this is that it might repeat as well. So what I can, and I think actually it might repeat even on the other one, or if I didn't do this. So let's go probability. Here it is. For this one, it has random int no rep, so it won't repeat if I do this. So 1, we'll do 28, and then we want 4 hotels, so we paste that, and it will not repeat. So there's our sample for that. Now that's just for the 80 series, but I've already told most of you, or I've told you that we're going to be using the Inspire to do this. So on the Inspire, open up to use it, go to the home screen, hit new document, and do calculator. Okay. On the calculator, all you need to do is type, you got the keyboard at the bottom, RANDINT, and then put parentheses and put your 1, the commas down here, 28. Okay? And that's going to do 1 at a time, and yes, it will repeat. So if you want to do it quicker, you can, if you press up on the little directional pad here, I'll click it, you can hit enter to copy, go back in there, put another comma, and this third number will be how many you want to get. So we want 4, so I hit enter, and then you can just do samples all day long here, and you'll see here how that one repeated. There's no function on here that stops it from repeating, okay? But if I just keep hitting enter, oops, it'll just keep generating samples. All right, so that's how we do random samples. So we're going to stop our lesson there. You have a worksheet that you can do, or that you need to do, and get turned into me on Kitim. If you have questions, feel free to email me or send me a remind.